Hi, everyone. I'm Steve McGhee. I'm a reliability advocate at Google Cloud. This is a picture of me in black and white. So today I'm going to talk to you about SLO classical literature. Last time you may have seen the talk I gave last year was called SLO Math. So this is sort of a follow-up to it. We're going to be a little bit more right brain, so less mathy and more literature. So why literature? Aren't we talking about computers here at this conference? Yeah, sure. But these are all computer systems that are built by humans, teams of humans, actually. And generally, we call this combination of humans and machines, a socio-technical system. So this is sometimes the actual system under test, the system that we need to manage as SREs or as engineers. So I think this will be, if anything, maybe just a different kind of talk, and hopefully a bit entertaining. So these are 5 points we're going to talk to. These all come from ancient Greek literature. So we're going to have a little bit from Herodotus, then Zeno, the Odyssey, you may have heard of, by Homer. Then we're going to talk about Plato's Cave. You've probably heard of that one before. And then we're going to go back to Homer again and talk about a kind of a modern theory that is based on 2 books of Homer's, both the Iliad and the Odyssey. So let's go to it. So we're just going to do one slide per topic. It's a bit dense, but it kind of gets everything on one page. So I think that's kind of helpful. So first up is Herodotus. So he was from 484 to 425 BCE. He was known as the first historian. He was the guy who wrote something called the Histories, big surprise. So he was considered the first person to do a systematic investigation of historical events. He was essentially interpreting and writing down existing stories. So this is a bit like what you're doing when you're first developing SLOs. What you're doing is you're actually taking cultural norms from within your org and you're understanding them and you're applying some structure to them. You should know that the process of doing this can actually be quite tedious. This may involve, interviewing people and writing things down. This might be many interviews. They might be contradicting reports, and your job is to make sense of it all. You should make sure that your goal is not perfection, but actually just getting something written down, so that future generations can iterate and refine. You might be one of those future generations. It might be next week, but the goal is just to get something down that can be improved upon. And what you're going to do is you're going to come up with a common understanding, which is recorded. It's going to basically result in less time wasted in the future on ambiguity or continual relitigation of processes or goals, because you're going to have a common understanding of what that is. Next up, we have Zeno. So you may have already heard Zeno's paradox, his first paradox, which is about going halfway and then halfway again and then halfway again and halfway again and never actually reaching your destination. This is very similar to that. So this is about Achilles racing a tortoise, and every time Achilles makes progress, the tortoise also makes some progress, just not quite as much, but it does count. So both of these are very similar in that they both deal with sort of infinities. They also deal with asymptotes, and so you can see this other picture on the side here. This is an asymptote that I want you to kind of remember, and these are the asymptote of nines. So this is the idea that when we are getting more and more nines over time in our SLOs, they are harder and harder to get. So it's sort of a similar paradox in my mind. So first off, I want you to kind of answer this question to yourself. To you, is 99.99 pretty much the same as 100? This is the paradox that should be kind of in your head right now. So the idea is that the closer that Achilles gets to the tortoise, the closer you kind of have to squint to see the difference between them, right? He's going to get closer and closer and closer. And if you keep looking really, really tight, you can still see there's still that gap. The tortoise is still making some progress. So why does this matter? What's the point? To humans, the race between Achilles and the tortoise is ridiculous at face. In reality, it's silly. No one ever really expects that Achilles is not going to reach the tortoise. The point of the parable is to point out that at smaller and smaller scales, there is a perceivable difference, even an infinite number of them. if you could really look that closely, whether it's that small amount of room or that fast of a window. Of course, as humans, we can't look that closely. A race between a demigod and a land reptile, you really can't tell the difference. But computers, they actually do act in this domain. They are really good at doing super fast, super high precision measurement things. So the parable actually makes a little bit more sense in the computer world. So it allows us to kind of go past our natural abilities of like our eyes and imagine this infinity. And this is in fact useful when it comes to dealing with computers that work at these high rates of change, very, very small amounts very quickly. It basically allows us to understand these nines a little bit better. So if you said in your head at the beginning, is 99.99 actually pretty much the same as 100? If you said yes, this is the problem we're trying to fix. We want you to be able to say no. There's actually like a big difference here. The difference between 4 nines and 100 is, based on this parable, infinite. It's actually very, very large, depending on how close you can perform a measurement. So if you can get to the point where you're saying there is a difference here, you're making a huge leap forward towards a better understanding of reliability. Okay, Odysseus and the Sirens. You may remember this story. So this is when Odysseus has his sailors plug their ears, and he says, "Tie me to the mast, and whatever you do, don't cut me down." And they're good sailors, and they sail through, and they succeed. So this is important. When you're defining what is an emergency and what isn't an emergency, part of the unwritten understanding is that you're actually going to stick to that definition. So like when you go and look at a graph on some sort of monitoring system for no reason, looking for a problem, you're going to find one. So don't do that, right? Like distributed systems are always slightly broken, but if the customer can't tell, it doesn't matter. SLOs should be your way to determine whether a system is actually bad or not. So once you've decided that something is bad, your goal should be to get back into SLO and no further, right? Avoid heroics. Don't try untested things if you can avoid it. So this also implies you should have a plan. You should test things. You should have emergency use scripts that are ready to go and that have been tested. So Odysseus' sailors knew what to do, and they had done drills. They knew how to sail the boat in this case and how to listen to orders. So dirt tests are similar to this, right? Doing testing ahead of time, doing drills, if you want to call them that. You want to pretend that an SLO is violated. Okay, what are we going to do, right? What would you want available? What would you want at hand at the time? Would you want analysis tools, repair scripts, provisioning, automation system, things like that? So know what you would do in the case of an emergency, and then when it happens, follow that plan. Don't change course midstream, as I say. Okay, Plato's cave. Yeah, this is a really famous one. You may have heard of it. So in this Plato's cave, we are all the people chained in the dark. You can see sort of at the bottom left corner. We can only see the shadows. We can't see the true objects. That is, we can't actually see our running systems, and we never will be able to. We are chained in that cave. All we can see is interpretations of the true items. We're only seeing shadows of our systems. They are running at many gigahertz across many machines, all in parallel. Like, can you really expect your human brain to fully understand that? You're really just approximating what's going on with the system. So the point of this is that your observability system will never be perfect, and you have to be okay with that. You have to be aware of it and okay with it. Even better than being just aware of it is knowing the limitations of this view, and then taking that delta into account when you're making decisions about taking action. Sometimes this can be like understanding statistical tools like percentiles and how they relate to the underlying distribution. Sometimes it's more about understanding your own always changing application and architecture. Like this file descriptors is our current bottleneck, which maxes out at some amount, and this may change over time. You're understanding approximations of the system, not the true system itself, and that's fine. You have to just be sort of meta aware of that. But at the end of the day, all of these metrics, logs, traces, whatever, they all are dependent on your architecture and your implementation. They're great for debugging, but they do have a tendency to skew over time, or they may have coverage gaps, especially if you have new features or you have infrequently used code paths. So it's not always going to be perfect. SLOs, on the other hand, should be far more stable descriptors of your service that actually could survive re-implementation. they should represent the nature of your service, not the internal mechanism of how it's built. So we could say that they're closer to the actual form than they are of the shadow. So hopefully these are what you can get out of SLOs is something that is closer to, but still not the same as the actual system under test. Okay, almost done. This one's going to be a bit of a stretch, but bear with me. So if you've ever seen the show Westworld, which is the picture is this is a character from the show, you may have heard of the idea of the bicameral mind, which is derived from a theory by a philosopher named James, or a psychiatrist named James, I think. So it's just a theory. It's certainly not universally accepted, but it is kind of fun to think through. Jane posits that mankind changed the way that it thinks, sometimes between the authorship of the Iliad and the Odyssey. Despite both are written by Homer, who may or may not be a single person, they're actually all derived from stories that lasted for a long time before that. So there's actually a fair amount of time between these two stories. There's evidence in the writings that suggests that the way people think about themselves and write down what their goals are is actually different in these two books, and this is what the theory is about. There's debate on whether Homer was in fact the author of both, but it doesn't really matter. So what Jane is saying is that the thing that changed is that people stopped, quote, hearing the gods as if they were like real voices in their heads. He claims that they were auditory hallucinations in the Iliad, that people actually heard these voices. And he said that these were, gods telling people what to do, and that was just taken as totally normal. But by the time that the Odyssey comes around, something else is taking place. The hero is not just subject to the gods, but is actually actively pursuing his own agenda. So he wants to get home. He even defies the gods and who are trying to stop him. They do definitely slow him down, but he is able to get past them. So what changed? If this is true, which maybe totally not true, but what did change? Did they actually like biologically evolve these humans in ancient Greece? Totally no way, right? This is only like a couple hundred years. This is a couple generations. There's no way like there was a whole new type of brain that was evolved or anything. So what Jane suggests is that actually it was the introduction of the introduction and popularity of the written word. The idea is that mankind had moved from an oral to a written tradition around the same time and was then able to share their narrative with each other, developing a new way to think about goals and how to achieve them, and they can all agree upon them. And it really just changed the way that people really thought. So what does this have to do with SLOs? I think that SLOs can be your chance to develop the narrative of your business's relationship with reliability. What is it that you're trying to actually achieve, and how are you going to measure it? What are you going to do when things go wrong? So your organization can develop self-agency. It means that you're no longer just interpreting these outages and data releases and other environmental issues as like undeniable voices of the gods, but as things that can be overcome. They're part of your own narrative, and you can take control. So by attaching business needs to their technical implementation, you're also de-siloing yourself. You're no longer just shrugging off incidents as unavoidable. No more, there's nothing we can do about that. You want to find yourself developing a more holistic model of reliability. So did we get all that? Do we believe it? Who knows? But it was fun to think about, right? So what are the takeaways? I think that through literature, society can find parallels between its current self and ancient texts. Each piece of literature can advance the society by changing the way people think. And I think we're part of a society. The IT ops or SRE or whatever you want to call a society is a society that spans many city-states or many companies today. By using SLOs as our narrative, we can develop a holistic model of reliability and self-empowerment, and we can make the internet more reliable. Thank you very much.